Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now we will be solving a question of P3 vectors. It's technically about intersection of lines, but what does it say over here? It's a bit difficult. So now let's look at the question. The question is of June 2022, variant 32, question number 9. There are two lines whose equations are given. Now what I have done is that I have written each equation in the expanded form. There are two unknown constants a and b, and the first part that is really tricky. It says given that lines L and M intersect, show that 2b minus a equals to 4. The other parts, they are straightforward, but the real part is the first one. So now what do? We say that if two lines are intersecting, let me use the red color. If two lines are intersecting, the x coordinates are the same and the y coordinates at that point of intersection is the same, and similarly the z coordinate should be the same. Now think about it. How should we get started? There is lambda, there is mu, there is a, there is b. So now it's kind of a difficult scenario. Now let me get started with the third equation because there are no unknown constants over here. So now the green line that represents the third equation, this is 4 minus lambda equals to 3 plus mu. Let's make lambda the subject. So 4 minus 3 minus mu equals to lambda, and hence lambda is 1 minus mu. So let me highlight it again. This is what I'll be working with. So now this was equation number 3 and I'm getting this thing which is the simplified version, which is equation 3a. Now let me look at equation number 2. So now let me focus on equation number 2. Which one is that? This is 3 minus lambda is 4 plus b times mu. 3 minus lambda is 4 plus b times mu. But what can I do? I can replace this lambda over here and I can replace it with this. So therefore 3 minus, put a bracket. This is 4 plus b times mu, and what goes over here, this is 1 minus mu. So now if I expand this equation, this is 3 minus 1 plus mu equals to 4 plus b times mu. And let's take all the mu's on one side. So therefore this is mu minus b mu. This is 4 plus 1 minus 3. And then this is mu common. 1 minus b and 5 minus 3 is 2. Make mu the subject, that is 2 over 1 minus b. Now this is the equation number 2. Let me write it over here. This is equation 2. And this one is the simplified version of equation number 2. So let me write this thing as equation 2a. Now two things are done. Now I have lambda in terms of mu. I have mu in terms of b. All good? So now let's go to equation number 1, which is minus 1 plus 2 lambda is equals to 5 plus a mu. So let me draw a red strip over here. And now let me write it. That is minus 1 plus 2 lambda equals to 5 plus a times mu. This is equation number 3. And 2 lambda, I'm making it the subject. 5 plus 1 is 6 plus a times mu. Now use this thing. That is the green one. Lambda is 1 minus mu. So but lambda is 1 minus mu. That is this green thing that we used earlier. So let me replace it over here. So 2 times 1 minus mu is 6 plus a times mu. And this is 2 minus 2 mu is equals to 6 plus a times mu. And let me take all the mu's to one side. So 2 minus 6 and this is 2 mu plus mu. Take mu common. This is a 2 and this is 2 mu and this is a mu. Okay, I just missed out the a. Let me write it properly. And this is a mu over here, mu common. This is 2 plus a, and 2 minus 6 is negative 4. In other words, mu is negative 4 over a plus 2. Now this is from the red equation that we got till this particular stage. Now let's recap the whole thing. These are not easy 4 marks. That is why they have given the proof. If someone is getting stuck in this, they can still get the rest of the 6 marks. The x coordinates are the same, the y coordinates are the same, the z coordinates are the same. The z1 is the easiest to work with. I made lambda the subject, lambda in terms of mu. That is the first one. Then over here, I used the second equation. I made mu the subject. That is in terms of b. Over here, I made again mu the subject. Now it's in terms of a. In both of them, I have used this relationship, lambda in terms of mu and lambda in terms of mu. Now the red one should equal to the blue one. So this is equation 3a simplified, and equate equation 3a with equation 2a. So 2 over, how much is that? This is 1 minus b. That should equal to negative 4 over a plus 2. So therefore 2a plus 4 equals to negative 4 into 1 is negative 4 plus 4b. And what is the format that I need the equation is? That is 2b minus a is equals to 4. Okay, so now let me take this 4 to the other side. That makes it 8. And this is 4b minus 2a. And yes, I'm almost done. Divide by 2. 4 is equals to 2b minus a. And hence, I have proven this thing. So 4 is 2b minus a, QED, quod erratum demonstrandum, something like that, but quite easily done. So now this thing is proven. So now the first part is done. Let's move to the next one. Part B. Let me highlight it. Now part B says, given that L and M, the two lines are perpendicular, find the value of A and B. That means form one equation based upon perpendicularity, solve it simultaneously with this equation. So now if we know that if line L is perpendicular to line M, therefore direction vector of L dot product with direction vector of M should equal to 0. So what is the direction vector of L? That is 2, negative 1, negative 1. What is the direction vector of M? That has the A and the B and the 1 over here equals to 0. So that's 2 times A, negative 1 times B, negative 1 times 1 should equal to 0. 2A minus B minus 1 equals to 0. 2A minus B equals to 1. That is equation number 2. What is equation number 1? That is 2B minus A equals to 4. So equation 1, 2B minus A equals to 4. Make A the subject. That is 2B minus 4. So let's substitute it over here. In place of A, write 2B minus 4. 2 times 2B minus 4 minus B equals to 1. 4B minus 8 minus B equals to 1. And then 4B minus B, that is 3B. Minus 8 taken to the other side, 1 plus 8 is 9. Therefore, B comes out to be 3. What is A? A is 2B minus 4. That is 2 into 3, 6, 6 minus 4. That comes out to be 2. So therefore, the value of A is 2. The value of B is 3. And let me also evaluate one of the things. I have mu, that is minus 4 over A plus 2. And mu is minus 4 over A plus 2. That is minus 4 over 2 plus 2. That comes out to be minus 4 over 4, which is negative 1. And what about lambda? Can I evaluate lambda? Yes, lambda is 1 minus mu. And over here, lambda is 1 minus mu. That is 1 minus minus 1. That comes out to be 2. So now for this particular level, I was just interested in A and B because that is what the examiner has asked. Another 4 mark, and these were the easy 4 marks. So part B was too easy to compensate for the very, very difficult part 1. And now what's the last thing? The last thing is when A and B have these values, find the position vector of the point of intersection. So the position vector of the point of intersection can either be obtained from here or from here. Over here, you have to plug in A, B, and mu. Over here, you just have to plug in lambda. So I think I've already found lambda. That was my ulterior motive. Based upon A and B, I found mu. I found lambda. And this is the part. So lambda is coming out to be 2. So I'll just plug it in this one. So therefore, we have minus 1 plus 2 lambda, minus 1 plus 2 times 2. And then 3 minus lambda, 4 minus lambda, 3 minus lambda, 4 minus lambda. This is what? This is R because the point of intersection is the same. So therefore, R equals to 4 minus 1, that is 3. 3 minus 2, that is 1. 4 minus 2 is 2. So this is the position vector of point of intersection. It's a good idea to write it in the IJK form. That is 3i plus j plus 2k. And let me check the thing. 3i plus 2j plus j plus 2k. 3i plus j plus 2k. And that is how this particular question is done and dusted. Stay tuned for more content on mathematics with Shahab Yaqub.